Welcome everybody. Today we are going to discuss about ring counter. So what is ring counter? It is one application of shift register. Now what is shift register? The register which supports either shift left or shift right operation is called as shift register. So there are several applications of shift register. So one of the application of shift register is ring counter. So let's see what happens in ring counter. So in ring counter, output of last flip-flop is connected to the input of first flip-flop. So already we know that register is nothing but it is group of flip-flop. So in case of ring counter, what happens? Output of last flip-flop is connected to the input of first flip-flop. So let's try to understand ring counter with the help of logic diagram. So this is logic diagram of the ring counter. So here first of all I will explain you how this logic diagram of ring counter can be prepared. Now let's see how we can design 4-bit ring counter. So in order to design 4-bit ring counter, we will require 4 D flip-flop. So let us show those 4 D flip-flop. So let's assume that this is first D flip-flop, then second D flip-flop, third D flip-flop, and fourth D flip-flop. Okay, then let's give the label. Suppose this is flip-flop 0, this is flip-flop 1, this is flip-flop 2, and this is flip-flop 3. After that, let's give a label to the input and output. So suppose here input is D0, output Q0, D1, Q1, D2, Q2, D3, Q3. Now ring counter is application of shift register, and in case of register we know that same external clock pulse should be given as clock input to all the flip-flops. So now what I'm doing, I'm giving same external clock pulse as clock input to all flip-flops. Then again I told you that ring counter is application of shift register, and in case of shift register what happens, what we do, we connect output of one flip-flop to the input of next flip-flop. So same thing now I will do here. I will connect output of this flip-flop 0, that is Q0, to the input of next flip-flop. Similarly, this output should be connected to input of next flip-flop. This output should be connected to input of next flip-flop. Now what is feature of ring counter? So in case of ring counter, output of last flip-flop, so which is last flip-flop, flip-flop 3, so its output should be connected to the input of first flip-flop. Then again we know that in each and every flip-flop we have preset input. So here also we will have preset input. In this flip-flop also there will be preset input, and here also there will be preset input. Then flip-flop also contain one more input, and that input is clear. So let me show that clear input. So in ring counter what you have to do, preset input of first flip-flop and clear input of remaining flip-flop, they should be connected together. So see what I am doing, I will take connection from preset input of first flip-flop, okay, and I will take connections from clear input of remaining flip-flops. So preset of first and clear input of remaining flip-flops, they should be connected together, and we will call this input as external input. You can give any label. So here I will give label as external input. So here what we did, simple, we have simply connected preset of first flip-flop and clear input of remaining flip-flops together. Then what to do with the clear input of first flip-flop and preset input of remaining flip-flop? So again we know that preset and clear, these are active low input. So if you want to use them, then they should be connected to logic 0, and if you don't want to use them, then they should be connected to logic 1. So here I don't want to use clear input of flip-flop 0, I don't want to use preset input of flip-flop 1, flip-flop 2, flip-flop 3. So that's why these inputs, so clear input of first flip-flop should be connected to logic 1, and preset input of remaining flip-flop should also be connected to logic 1. I can say that this is final logic diagram of 4-bit ring counter. So in this way we have seen how logic diagram of ring counter can be prepared. Now let's proceed. In case of ring counter, the flip-flops are connected so that information shift from left to right and back around from Q3 to Q0. So in case of ring counter, what happens? The information which is represented by Q0, so that information will be shifted into Q1, Q1 will be shifted into Q2, Q2 will be shifted into Q3, and again Q3 will be shifted into Q0. In most cases, there is single one in the register and it is made to circulate around the register. So in case of ring counter, what happens? There is single one present in the register. So if we consider an example of this 4-bit ring counter. So this 4-bit ring counter is made up of 4 flip-flop. So out of this 4 flip-flop, at a time only one flip-flop will carry 1 and remaining flip-flops they will have output 0. So in ring counter, what happens? That single one is made to circulate around the register. So initially that one may be in flip-flop 0, then it will be shifted into flip-flop 1, then it will be shifted into flip-flop 2, and then it will be shifted into flip-flop 3. And again from flip-flop 3, that 1 will be shifted into flip-flop 0 and it will continue. Now let's try to understand operation of ring counter. So here let's take example of 4-bit ring counter. So in case of ring counter, first of all, what you should do? You should apply logic 0 to external input. So when we apply logic 0 to external input, what will happen? So here please try to understand how this external input is formed. So this external input is formed simply by connecting preset input of first flip-flop and clear input of remaining flip-flops together. So when we apply 0 to external input, so this preset will become 0 and clear input of remaining flip-flops will become 0. So what is feature of preset and clear input? So we know that preset and clear input are active low input. Also preset and clear inputs are asynchronous. So they are asynchronous. Why? Because their operation is not dependent on the clock. So whenever either preset or clear becomes active, immediately at that instant only output of that particular flip-flop is going to change. For example, now for flip-flop 0, so preset is active. So preset is active, so that's why output of this flip-flop 0 will become 1. Similarly, for remaining 3 flip-flop, clear input is active. So whenever clear input is active, output of that flip-flop will become 0. So here I can say that our ring counter has entered in state 1 0 0 0. Now let's try to understand operation of ring counter with the help of table. So in that table, first of all, I will show Q0 followed by Q1 followed by Q2 followed by Q3, and at the end let us show clock. Now initially you should not give any clock pulse. Okay, simply what you should do, you should make external input 0. So when this external input becomes 0, what will happen? Ring counter will enter in state 1 0 0 0. So just now we have seen. And after this what is next step? After this you should make this external input 1. So when we make this external input 1, what will happen? Preset input of first flip-flop will be at logic 1 and clear input of remaining flip-flop will be again at logic 1. So by applying 1 to external input, what we did, we have made preset and preset input of first flip-flop and clear input of remaining flip-flops inactive. After this, what is next step? We should give the clock pulse. So when we give clock pulse, what will happen? So see here, same external clock pulse is given as clock input to all the flip-flops. So that's why due to this single clock pulse, all flip-flops will be triggered at same time. So output of all this flip-flop is going to change as per their input. So here, first of all, what we have to do, we have to find out the flip-flop inputs. So let's try to find out input of each and every flip-flop. So let's start with flip-flop 3. So what will be the input to this flip-flop 3? Yes, so Q2 is connected to D3. So here I can say that input to this flip-flop 3 will be 0. Similarly, what will be the input to flip-flop 2? So see, Q1 is connected to D2. So that's why I can say that D2 will be 0. What will be the input to flip-flop 1? So Q0 is connected to D1. So that's why I can say that D1 will be 1. What will be the input to flip-flop 0? Now see, Q3 output of flip-flop 3 is connected to D0. So what is Q3? Q3 is 0. So that's why I can say that D0 will be 0. So when we give clock pulse, output of each and every flip-flop is going to change as per input. And in case of D flip-flop, we know that output follows input. Whatever input we apply, so same will become the output. So now let's try to find out new output of each and every flip-flop. So let's start with flip-flop 3. So what will be the new output of flip-flop 3? Yes, new output of this flip-flop 3 will be 0. Actually, this output of this flip-flop 3, it is not going to change. Previous output was 0 and next output will also be 0. Similarly, what will be the new output of flip-flop 2? So see, here input is 0. So that's why I can say that new output will be 0. Then for flip-flop 1, previous output was 0. Now what will be the new output? So new output will be 1. Why 1? Because input to flip-flop 1 is 1. Similarly, what will be the output of flip-flop 0? So new output of flip-flop 0 will be 0. So what is next state? What is new state of ring counter? It is 0, 1, 0, 0. So let's write that new state of ring counter here, 0, 1, 0, 0. After this, what we should do? Again give one more clock pulse. So when we give one more clock pulse, again same thing is going to happen. All flip-flops will be triggered at same time. Output of all this flip-flop is going to change as per their input. Now here, what we should do? We should find out flip-flop inputs. So let's try to find out flip-flop input. So what will be the input to this flip-flop 3? So previous input was 0. Okay. Now new input will be this 0. For flip-flop 2, this 0 was previous input. New input will be 1. For flip-flop 1, this 1 was previous input. This 0 will be the current input. For flip-flop 0, this 0 was previous input and current input is also 0. Okay, so after giving this second clock pulse, what will happen? Again, output of each and every flip-flop is going to change. So let's try to find out new output of each and every flip-flop. For this flip-flop 3, what will be the new output? So new output of flip-flop 3 will be 0 because here input is 0. Similarly, for flip-flop 2, this 0 was previous output, new output will be 1. For flip-flop 1, this 1 was previous output, now new output will be 0. For flip-flop 0, this 0 was previous output, now new output will be 0. So here I can say that now our ring counter has entered in state 0, 0, 1, 0. So 0, 0, 1, 0. So here try to understand what is happening in ring counter. Okay, so in case of ring counter, there will be only single one. In case of ring counter, there will be only single one which will be present in one of the flip-flop, and that single one will go on circulating through different flip-flops. Whenever we apply one clock pulse, so that single one which is present in one of the flip-flop will be circulated through different flip-flops which are present in ring counter. So after this, what is the next step? Again give one more clock pulse. So let us give one more clock pulse. So again all flip-flops will be triggered. So here what we should do? We should find out flip-flop inputs. In order to find out new outputs, here first of all we should find out flip-flop input. So for flip-flop 3, what will be the inputs? Yes, so for flip-flop 3, this 0 was the previous input. Now this 1 will be the current input. Then for flip-flop 2, this 1 was previous input. Now new input will be this 0. For flip-flop 1, this 0 was previous input. Now new input will be this 0. Similarly, for this flip-flop 0, this 0 was previous input. Now new input will be this 0. So when we give clock pulse, what will be the new output of this 4 flip-flop? Okay, so very simple. So see, for flip-flop 3, what will be the new output? So this 0 was previous output. So now new output of flip-flop 3 will be 1. Now this 1 was previous output. For flip-flop 2, new output of flip-flop 2 will be 0. Then for flip-flop 1, this 0 was previous output. New output of flip-flop 1 will be this 0. Okay, for this flip-flop 0, this 0 was previous output. New output of this flip-flop 0 will be again 0. So what will be the next state of the ring counter? It will be 0, 0, 0, 1. Okay, so let me write that next state of ring counter here, 0, 0, 0, 1. So see that 1 has been shifted from Q2 to Q3. After this, what we will do? Again, we should give one more clock pulse. So here we will give one more clock pulse. So when we give one more clock pulse, again same thing is going to happen.
all flip-flops will be triggered, so their outputs are going to change as per input. So here we should find out input first. For flip-flop 3, this 1 was previous input, new input will be 0. For flip-flop 2, 0 was previous input, new input will be 0. For flip-flop 1, 0 was previous input, again new input will be 0. For flip-flop 0, this 0 was a previous input and new input will be this 1. Okay. So let's find out new output. So for flip-flop 3, what will be the new output? Yes, this 0. For flip-flop 2, what will be the new output? Yes, this 0. For flip-flop 1, what will be the new output? Yes, this 0. And for flip-flop 0, what will be the new output? Yes, this 1. So what will be the new state of the ring counter? It will be 1, 0, 0, 0. So let me write that new state here. So 1, 0, 0, 0. Now focus on this first state from where we started and the state that we are getting after 4 clock cycle. So here you will come to know that this first state and the state which we are getting after 4 clock cycle both are same. So here you can easily verify that after this if you give clock pulse, then same states they are going to repeat. In case of ring counter, in case of 4-bit ring counter, can you tell me how many states will be there? So here I can say that 4-bit ring counter has, yes, so how many states? So see here, this is first state, then this is second state, this is third state, and this is fourth state. So we can say that in case of 4-bit ring counter, we will have how many states? 4 states. Similarly, you can verify that if we have suppose 8-bit ring counter. So 8-bit ring counter will have how many different states? So there will be 8 different states. In general, we can say that if we have n-bit ring counter, then that n-bit ring counter will have how many states? How many different states? Yes, n different states.